I've been asked to have a look at this Breville toaster. The levers won't stay down when it's powered up, and it's the model, possibly the VTT702. Anyway, it's the 1720 to 2100 watt version, and look as though there's some screws on the outside here. But I think first off we have to take these knobs off. Now the knobs have got a little slot underneath that a peg on the bar that goes up and down slides into, and you can pull them off, but you may just have to push the plastic back to release the peg from the little slot that's in the underside. But be very careful because it can snap, so you don't really want to move that plastic very far at all. So we've got 4 crosshead screws, 1 in each corner. And we've got 2 T10 Torx heads. Just a little catch on here. Just have to press the bit that you can reach, and it releases the lever to release from this, where the timing mechanism is in here. So now that we're in, I've had a chance to have a look, see how it works. And you've got 2 levers on the come through from the inside to the outside. When they go down, this electromagnet obviously holds this in place, placing your fingers on there, and then the electrical timing mechanism, which is attached to here, must release these. The boards, if you want to have a look at those, they're released with some clips in here. Just gently ease those back. There's 2 of them, unfortunately, so it's a little bit tricky. And you can lift the board out and have a look. And here you can see the contacts. This is the negative side contact. That's the positive side contact. When you operate the lever, a piece of plastic comes down, rolls into that space, and closes these contacts here. It also closes these contacts here. That energises not only the heating elements, of which there are 3, but it also energises through this red wire. There seems to be a tap off what is effectively a series of resistance wire. There's a tap off here, goes through this coil. There's a few other components here which I've put on the drawing. And in energising that coil, when you lower this, operate the switch, energise the coil, these pieces of metal on here hold it down. In this particular case, they're not, although if you release it very slowly, it will hold. So I'm rather hoping that if I clean these contacts here, and the same ones on here, these look a bit dirtier, that it'll work. Now, this has two sides to it, a 1 and a 2. You cannot operate the 2 side, this side, without operating this side first. The power for this magnet comes from this board after the switches. So you have to operate this one for this side to hold in. And in fact, it's this side that has the timer mechanism attached to it. And it operates via a transistor in here to energise this coil, which again, like that side, it's these metal plates which hold onto this magnet that hold this down. And unless this one is down, neither side will operate. I've got a contact file here, very, very smooth. It's specifically for cleaning contacts. You could use something like 400 or 600 grit emery paper as well, I suspect. The contacts are a little bit black, but they're not excessively pitted. I spent a few minutes cleaning the 4 sets of contacts off, and I'm hoping that that should be enough to get this thing working again. Let's pop the cover back on then. We've got to reconnect this lead down in here. And then slide the levers through the slots at the front. That seems to be in place. Now power it up to get some idea of whether it's working. Well, I haven't screwed it up yet, but let's see how it goes. Oh, well, we've got a light on a switch. I don't know what that means. I was just instructed to make it stay down. I don't have to learn to make toast with it. Oh, yeah, that's getting warm. Don't know whether it'll pop up on its own or not, but I don't know. This is presumably different timings. It's got sort of sizzling toast, something with a cross on it, and defrost. So I don't know how long sizzling toast takes. I'll switch it off. Mind your ears. That seems to work. See, none of this comes on unless you actually operate. And of course this one doesn't work at all. Won't stay down until you operate this one. Ooh, we've got both on now. Ooh. So that's started. That's the other one started, so that does appear to work now. And if I press, yeah, they're both getting hot. Ready for the jump. Doesn't make you jump the second time. I think that may have done it. So cleaning those contacts does appear, for the moment, to have cured the problem. You can see that the live neutral and earth come in through the top right hand side there. Make sure that the earth is grounded on the metal chassis inside. That's very important. And then you've got a set of switches for the live and neutral. And as you can see, that goes across to the live and neutral on the number 2 side as well. Now, you see that the live goes down through the heating elements and then through to the neutral. But it also, with that tap off, which goes into the 10 ohm resistor and the diode, is where the feed is for the electromagnet. The electromagnet is also switched on the number 1 side by that 2N5551 transistor, which derives its control from the timer circuit. The capacitors there are just to cut out noise, and when the transistor switches on, the electromagnet switches on, and that's what holds the mechanism down. So obviously, if you operate the right hand side, the number 1 side, the switches come in, the heating elements are energized, the electromagnet's energized, the timer circuit is energized, it goes through its process, releases the electromagnet, the device shoots up, switches the switches off. And because it switches the switches off on the number 1 side, if you are using the number 2 side and the switches are in, of course, it loses its power to its electromagnet as well, because the number 1 side has released, and therefore the number 2 side releases. I hope that makes some sense.